We're given the logarithmic function f of x equals log base 5 of x and asked a variety of questions about the properties and characteristics of the function. Before we answer the questions though, let's graph this function and also write the log equation in exponential form. So using the change in base formula given here, using common logs, we could write f of x as f of x equals the common log of x divided by the common log of the base 5. We'll use this to graph the function in just a moment. To write this equation in exponential form, let's replace f of x with y and write this as y equals log base 5 of x. In this form, we should recognize the base is 5, the exponent is y, and the number is x. Therefore, this is equivalent to the exponential equation 5 raised to the power of y equals x. Now let's go ahead and graph this log function. So we'll press y equals, type in common log x, close parenthesis, divided by common log 5, close parenthesis. I did adjust the window to get a better view. The x values go from -2 to 10, and the y values go from -10 to 2. Let's go ahead and press graph. Here's our logarithmic function, which we will use to answer some of the questions. But I did reproduce this graph on some different software so we can better analyze the graph. So we'll actually be using this graph here to analyze the log function. The first question asks for the domain of the logarithmic function, which is a set of all possible inputs or all possible x values. To do this analytically, I think it's helpful to look at the exponential equation here. We're thinking about what values we can get for x if x is equal to 5 raised to the power of y. Whatever power we raise 5 to, x is never going to be negative. It's also never going to equal 0. And therefore the domain would be x is greater than 0, or the open interval from 0 to infinity, using interval notation. If we look at the graph of our function, notice how it never equals 0 because we have a vertical asymptote here. Notice the x values are only to the right of x equals 0, verifying the domain is the open interval from 0 to infinity. Next, we're asked about the range of the log function. Again, looking at the exponential form, notice how we can raise 5 to any real number, and therefore the range would be all real numbers, or the open interval from -infinity to +infinity. Going back to the graph, notice how the graph goes down forever, and even though it is moving right very quickly, it's also moving up forever with no breaks, verifying our range is all real numbers, or the interval from -infinity to +infinity. And now to find the horizontal intercept, which is the same as the x-intercept, we set f of x or y equal to 0 and solve for x. To do this, we'll use the exponential form. Notice how if we set y equal to 0, we would have the equation 5 to the 0 equals x, so x equals 5 to the 0, which is equal to 1. So if the x-intercept or horizontal intercept is 1, or the point 1, 0. We can easily verify this on the graph. Here's the horizontal intercept, which is the point 1, 0. Next, we're asked to find the vertical asymptote, and we briefly discussed that. Notice how as x approaches 0 from the right side, the function values decrease without bound and approach -infinity, and therefore we have a vertical asymptote at x equals 0. Next, we're asked to find the vertical intercept, which should be the same as the y-intercept, so we set x equal to 0 and solve for y. So again, using the exponential form, if we set x equal to 0, this would give us the equation 5 to the power of y equals 0. And we discussed earlier, we can't raise 5 to a power and get a value of 0. It's always going to be positive, and therefore this does not have a solution, which means we do not have a vertical intercept, or we do not have a y-intercept. So for the homework, we'll type in DNE, for does not exist. Now we're not done here, we still have more questions. I notice there's a typo here. This should say, what is the left to right behavior, describing it as increasing, decreasing, or constant. So going back to the graph, notice as x increases, the function values also increase. So this function is always increasing, but notice as x increases, it does not increase as fast, and therefore we can say this function is increasing, but it's increasing at a decreasing rate. So again, this answer here is it's increasing, but it's increasing at a decreasing rate. Next, we're asked to determine the values for which the function is greater than 0, which would be when the function is above the x-axis. So looking at our graph, notice how the function values, or y values, are greater than 0 or positive above the x-axis, and therefore we can say the function is positive when x is greater than 1. Notice how it does ask us to use inequality notation, not interval notation. So we'll type in x is greater than 1. Next, we want to find the values of x for which f of x is less than 0, or negative, which would be when the function is below the x-axis. Well, if we just said the function was positive or above the x-axis on this interval, that means it would be negative or less than 0 when it's below the x-axis or over this interval here. But remember, the domain is the open interval from 0 to infinity, so this would be when x is greater than 0 and less than 1. So as a compound inequality, we would say x is greater than 0 and less than 1. Next, we want to find the value of x for which f of x equals 0, which would be where the graph crosses the horizontal axis, or x-axis. So the function value equals 0 right here at the horizontal intercept of x equals positive 1. And now for our last question, we want to find the value of x for which f of x equals 1. Remember, f of x is the same as y, so we want to find the value of x when y equals 1. To do this, we'll use the exponential form, where if y equals log base 5 of x, then 5 to the power of y must equal x. So 5 to the power of y equals x. We can substitute 1 for y. 5 to the 1 equals x, so x equals 5. We can verify this on our graph. Here's where x equals 5, right on the edge. And notice when x equals 5, the function value is positive 1. So there's a lot of good information in this one question. I hope you found this helpful.